So this video is to help you with your word problems. That's what this activity is about, is practicing with word problems. You're going to open a PowerPoint, and at the bottom of the PowerPoint you're going to have these little cards that you can drag up to where they belong. So under inequality, you're going to put one of these inequality equations. Solution is going to be the equation, or what you get when you solve the inequality for x. But let's talk about the word problems a little bit. These are the ones without x and y. There's just one variable in this. There's just an x. You can call it x, m, whatever you want to with the letter. But let's look at the words here. And I know on this one, it's kind of easy on this to go and just kind of read the words and guess which ones go in, but I really want you to logic your way through this so that you're sure to get these word problems down, because they all have consistently the same pattern. If you look at the A, B, C, D below, you have something times x plus something, or something times x minus something, and then you have an inequality and a total. So there's two slides in your PowerPoint you're going to do. This first one, I'm going to do number 1 with you. So Blake is saving to buy up a new pair of headphones. I'm going to put this down here though. He has $20 saved already. He earns $10 for every lawn he mows. How many lawns will he have to mow to save at least $90? So there's 3 things that you're looking for. One is the per phrase, and then you're looking for a constant phrase, and then an inequality phrase. So the per phrase, this one doesn't have a per in it, but you're looking for the number where you could change the phrase that comes after it or before it to something like per. So $20 saved already. We can't really say that, turn that into a per, but $10 for every lawn, I could say $10 per lawn. So this would be our per phrase for this one, because I can change that to $10 per lawn. The constant is like a fact. It's something that is already there, is going to be taken away. It could be money already in the bank. It could be minutes already saved. It could be height already reached. Or it could be a discount where we subtract it. So for this one, he's saved $20 already. So that's our constant. The $20 is just a fact. It's not going to change. It's always $20. That's how much he has saved. Okay, and then the inequality phrase is the inequality word. So we're looking at least $90. So I want you to think about this. He needs to have $90 is okay, but more than 90 would be better. So we're going to turn this one into an inequality. We'll put 90 right here, and the money that he saves, we want to be bigger than $90, but it can equal $90. So now we're going to just take the rest of this and turn it into an equation. $10 per lawn would be like 10 times, if I call per lawn the number of lawns, I'm going to call that x. So this is my define a variable statement. So if I say define the variable is x equals the number of lawns. Okay, so 10 times the number of lawns, because per goes with multiply, right? And if I add to that the money that he already has, then it needs to be greater than or equal to 90. So right here is our inequality that we're after for this problem. And then if you solve it, you take away 20 from both sides, you get 10x is greater than or equal to 70. And then you divide by 10 as x is greater than or equal to 7. And we can always check this and make sure that we got it right, because if I go and I put 7 in for 10, 10 times 7 plus 20 is greater than or equal to 90. I get 90 is greater than or equal to 90. So that's my check step. 7 is a solution to this inequality. It's in the solution set, and so are all the numbers that are bigger than 7. But the minimum he makes is $90. So what we're going to do then is we're going to take the 20 plus 10x plus, not that one. We're going to take the 10x plus 10, 20, 10x plus 20 is greater than or equal to 90, and we're going to move it into this inequality spot right here. So there's our inequality that goes with it. 10x plus 20 is greater than or equal to 90. And then we're going to take the x is greater than or equal to 7. Okay, we put that in there and we have x is greater than or equal to 7 as our solution. Now just be aware in the test I'm going to ask you to write a sentence equation. I'm going to ask you to write that he must save or must work at least 7 hours. Or, jeez, he's working on lawns, so he must mow at least 7 lawns. You don't have to do that on this assignment, but if you need some practice, you might write it on there. Okay, so just to recap, find each of the inequality phrases in the words. Let me clean this up a little bit. Okay, find your per phrase, find the constant, find the inequality phrase, create an inequality, solve it, and then match your choices. Do this within the PowerPoint. Remember, when you save in Teams, it automatically keeps track of your progress, and I look forward to seeing your work. Have a good day.